Hello, boys and girls. So you are at the point in the Ed puzzle when you should be looking at this diagram on the slide. So I kind of wanted to give you some tips before you move on with the questions on the next slide. So basically what we're looking at here is a map of the United States. And on the map, we have four different air masses. So we have two blues and two reds. And each of these air masses is labeled. For example, we have on the top left, we have a maritime polar. We have a continental polar. We have a continental tropical. And we have a maritime tropical. All right, so within each of these air masses, there is also three letters for locations. So for each of these letters, like we have an A, B, C, if you take a look at the chart below, letter A, B, C that are in that air mass on the top left, A, B, C, the air in that air mass, remember an air mass is a huge pocket of air that has similar characteristics. So in A, B, C, the temperature of that air you can find here. Each letter has a temperature. Each letter has a humidity level. That's in percentages. That's how wet or dry the air is. And then you also have a cloud cover for each of the letters. So if we look at A, B, C, we can tell from the temperatures that they're a little bit on the colder end. Okay, they're all less than 50 degrees, which is kind of a chilly temperature. Humidity, the humidity levels are high. They're 85, 80, and 86. So that would be a high humidity level. And the cloud cover is either partly or mostly cloudy. So if we look at A, B, and C, this maritime polar air mass, cold temperature, polar. Humidity's high because it's maritime. It formed over water. So it collected all that water over what it formed. And if you have a maritime polar air mass, it's going to cause cloudy or partly cloudy weather or cloud cover. So that would be A, B, and C. Then we move to, we have IGH as well. This is a continental polar. So again, I, G, and H, which down here on the chart, we have GHI. Again, it's polar, so the temperatures are cold, even colder than before in the previous polar we looked at. But now the humidity levels, they're a lot less, and that's because it's continental. It formed over the land, so it didn't have that moisture from the water like a maritime air mass would have. So these are much lower humidity levels. And this time we have sunny skies, or mostly sunny. So it looks like continental air masses produce more sunny weather, while your maritime produce more cloud-type weather. So those are our two blue air masses. Then we have our reds. Well, continuing the process, this first red, EDF, is a continental tropical. So if we look at E, D, and F, let me first erase these so we don't get super confused here. So if we look at E, D, and F, yeah, E, D, F, so E, D, and F's right here, we have warmer temperatures, actually nice and warm in the 80s. That's because it's a tropical air mass. Okay, it's not polar, it's tropical now. It formed over a warmer area. We have low humidity because it's continental. It formed over the land. It didn't have that water from an ocean to make it moist and higher humidity. And again, we have mostly sunny or sunny weather because it's continental. Continental again goes with sunny or partly sunny skies. And then lastly, we have our maritime tropical on the bottom right. And that would be letters, what is it, J, K, and L. And here we are. Again, since it's tropical, we have warm temperatures. And since it formed over the water or maritime, it's going to be high humidity from that water it collected as it formed. And since it's maritime, we also have mostly cloudy or partly cloudy as a result. So we can tell a lot from these air masses. Again, they're huge pockets of air, and they move, and wind causes them to move. So as they move around, of course, they're going to affect the weather in that area. And we have certain air masses that constantly move over certain areas of the United States based on where they formed and how they travel. And we're going to get to, I'm kind of going ahead a little bit right now, but I just want to mention this. You can probably assume that these air masses, they sometimes collide. Okay, so there's like a collision of air masses. And when they do collide, we call that a front. Okay, so when air masses collide, we have a weather front. And of course, that can cause even more different things with the weather, which we're going to talk about after these air masses. So now you can continue working on the next slide where there'll be some questions about what we just went over.